Assalamualaikum warahmatullahi wabarakatuh. Now we have reached back to our last topic in chapter 4, which is relative velocity and relative acceleration. Right, so for relative velocity, the best example that I can think of is our experience when we are inside a car which is moving, right? And we can see a lot of car which also moving with us, but some of them are actually moving with different speed, and seems like they were moving as different speed relative to us. Okay, but before I play the video, I would like to put some disclaimer that this video consists of of an illegal racer, street racing, which is not a good example. Okay, so illegal racing is very dangerous, and also it is very irresponsible. It can potentially danger to another driver in the street. Okay, so do not follow this example. Right, so the video is just to show you relative velocity that being seen by a driver. All right. Right, so let's see this video. So you can see as the driver is driving at high speed, we can see that some of the car, all right, are moving backward. Okay, you see this van, right, are actually moving backward. Right, so the car is actually moving forward. Okay, but some of the car which has different speed than the driver seems like or be seen as moving backward. Okay, so this is what is meant by relative velocity. Okay, basically all the car in this view are actually moving forward. Okay, but due to the difference in speed, all right, from the driver. Okay, so most of the car, right, or some of the car are being seen as not moving forward but moving backward. Okay, but since we are, our brain understood this situation, our brain has translated it well lah, kan? So we can see that we can understand that all the car are actually moving forward. Okay, but in terms of relative velocity, okay, if I play the video back, some of the car, especially if you look this van, okay, are actually be seen as moving backward with a certain speed. Okay, let's say, like 5 kilometer per hour. Okay, due to the difference in speed. So this is relative velocity. And if another car are moving faster than us, okay, so we can see that the car are moving forward, okay, with, let's say, I think around 5 kilometer per hour. Okay, and if the car, if another car is moving at the same speed as us, we can see that there is no change in speed, or we can see that the distance of the car are the same with us. Okay, as if the car are not moving at all. Okay, so that is relative velocity. Okay, so in terms of relative velocity, we emphasize on whose perspective are we talking about. Okay, so in the perspective of the driver, all right, the car just now, the red car, okay, are moving forward with 5 kilometer per hour. Okay, but the black car are not moving at all. Okay, because it has the same relative speed as the driver, while the red car just now are moving forward at 5 kilometer per hour, relative to the BMW driver. Okay, and in previous video just now, okay, the black car or the white car ni, okay, are moving forward with, let's say, 5 kilometer per hour. Okay, from relative to the Mercedes driver ni. Okay, but in the perspective of a stationary person, okay, the car are actually moving like this. Okay, so it's very fast. Okay, the car moving very fast, but in the perspective of the driver inside the car, so most of the car are moving very slow. Okay, so that is relative velocity. Right, so to analyze relative velocity is actually not that hard. We only use vector. Okay, so we have to use vector analysis to analyze relative velocity. Right, so consider a point P. Okay, consider a point P which are moving, and this point P are being seen by two person. Okay, observer A and observer B. Observer A is stationary. Okay, so it has a reference point of SA, right? And SA ni is not moving lah, since observer A is not moving. Okay, while observer B are moving with a speed of VBA. Okay, so in the perspective of A, right? Observer B are moving to the right with a speed of V. Okay, and how to read this notation? All right, so this is speed of B relative to A, which means this is the speed of B as being seen by A. Okay, so the first word ni is the speed of that, and then the second word is relative to. Uh, or as be seen by. Okay, so this is speed of B relative to A, or in other words, speed of B as being seen by A. Okay, so B will have its own reference point, okay, which is SB. Okay, and SB pun actually moving together lah, kan? So this reference point are fixed to B, right? And at a certain time, okay, so B will be moving at a distance of VT. Okay, so the distance that is being moved by B will equals to VBA times with T. Okay, right. So the object P, okay, that being seen by A, all right, will have a vector distance of RPA. Okay, so RPA means R of P relative to A. Okay, so R of P, so R of P relative to A, or as being seen by A. Okay, while observer B will see P and will have a vector displacement of RPB. Okay, so R of P, right, relative to B. Right. So we are now has established a vector triangle. Okay, and from this triangle, you can actually guess, right? Since we have learned vectors, so you can see which one of these three lines are the resultant and which two are the vector component. Okay, so it seems like all the line starts from A. Okay, two of it is two way is the direction is moving to B and then to P, can and then another line is straight away from A to P. So we can see that RPA ni is the resultant, while VT and also RPB is the two components. Okay, so we can write this triangle, okay, vector triangle, as RPA equals to RPB plus VBA T, or VB relative to A times with T. Right, so if you want to find the speed, okay, of any of the point, okay, so we can simply differentiate, right? We can simply differentiate the equation. All right, so differentiate PA over dt, right, equals to differentiation of RPV, RPB over dt, right, and also differentiate of these terms lah, V times with T. Okay, so as we differentiate all these three, right, so RPA will give us speed of PA, so speed of P relative to A, right, and then differentiation of RPB, right, will give us the speed of P relative to B, and differentiation of V times T, right, since V is a constant, right, so differentiation of dVt over dt, right, so it will give us VBA lah. Okay, so we have this equation, right, or another triangle represent the velocity. Okay, right, so in terms of acceleration, alright, so we just need to differentiate again the velocity equation or the velocity triangle. Okay, so du dupa dt, right, and then differentiate the second term dupb over dt, and then differentiate dvba over dt, right, then give us okay, so APA, right, equals to dupa dt, or as we differentiate dupa dt, it will give us acceleration of PA lah. Okay, and then as we differentiate du PB over dt, right, so it will give us A, or acceleration of P relative to B, right, and for VBA, since it is a constant, right, so as we differentiate a constant, it will give us a 0. Okay, so only two value that has acceleration, right, which is the speed of, the acceleration of P relative to A, and also the acceleration of P relative to B. Alright, so we can say that the two acceleration are the same. Okay, because from this equation, since yang ni equals to 0, so acceleration of PA equals to acceleration of PB. Okay, so let's see how we apply this in our last example. Right, example 4.8, a boat crossing a river. So a boat crossing a wide river move with a speed of 10 km per hour relative to the water. So we have VRE. So this is the speed, the vector of the speed of water or the river relative to the earth. Alright, since earth is not moving, is stationary, right? So the speed of water is 10 km per hour to the east. Okay, and then the water in the river has a uniform speed. Sorry, a boat crossing a wide river move with a speed of 10 km per hour relative to the water. Sorry, so the boat has a speed. Alright, the boat ni has a speed of 10 km per hour relative to the river, and then the water in the river has a uniform speed of 5 km per hour due east. Alright, so this will be the speed of the water, right, or the river, which is 5 km per hour to the east, right, relative to the earth. So if the boat head due north, determine the velocity of the boat relative to an observer standing on either bank. Okay, so observer ni is basically a stationary observer lah. So we can say the observer ni pun is earth. Okay, since it is also stationary. So the question asking for velocity of the boat relative to observer. In other words, velocity of the boat relative to the earth lah, which is this one. Right, so since we have a vector of the speed of river, which is moving to the east, and then it says that the boat are moving straight, moving due north. The boats ni are heading due north with a speed of 10 km per hour relative to the water. So the boat will have a speed of 10 kilometer per hour relative to the water, and it is moving straight forward to the north. Okay, and since the river are moving to the right, actually this is very logic. We know that the boat will be diverted to the right. Okay, so it will have a vector motion of VBE lah, which is to the right. Okay, so the question asking for the velocity of the boat relative to the observer, which is this one lah. So we want to find this vector. So from this triangle, you can see first you have to determine which one is the resultant and which one is the two component. Okay, so it's very obvious that VB or UBE ni is the resultant, and UBR and VRE is the component. Okay, so we can write the triangle as UBE equals to UBR plus VRE. Okay, but since the question are asking for the velocity of the boat, which means we just want this vector. Okay, so and since this triangle is a sorry, and since this triangle, okay, is a right triangle where this angle is 90 degree, so instead of solve it using a complex vector analysis, we can simply solve it by using triangle or trigonometry. Okay, so by using theorem Pythagoras, all right, so the length of the hypotenuse, okay, or VBE is equals to the square root of UBR square plus URE square. Okay, so put in the value. So we have UBE equals to 11.2 kilometer per hour. All right, and the angle of this triangle, okay, or the angle of the boat or diverted is can be solved by using tangent. Okay, so theta equals to tangent inverse opposite over adjacent, where the opposite is VRE, right, over dengan adjacent is UBR. Okay, which is 5 over 10, which then give us 26.6 degree. Right, next B, if the boat travel with the same speed 10 km per hour relative to the river and is to travel due north as shown in the figure, where should its heading be? Which means we want the boat to move in a straight line. Okay, so since we want the boat to move in a straight line, we cannot set the boat to move straight lah. Somehow we have to move, or we have to drive the boat to the left. Okay, as in figure or as this line, right? So that as this vector add with the speed or the vector of the speed of the river, then the boat will be moving in a straight line to the north. Okay, so the question asking for this speed lah. Okay, so the question asking for this speed. Right, so we know that this the speed of the boat relative to the river is 10 km per hour, and the river are moving 5 km per hour uh, due to east. Okay, so we simply solve this using theorem Pythagoras as well. Okay, where UBR equals to square root of UBE equals to square root of UBR square minus VRE square. Alright, since we are now looking for not the hypotenuse but the side angle, right? I mean the side line, right? So put in the value. So we have UBE equals to 8.66 kilometer per hour, right? And the angle we can solve it using tangent, right? So tangent inverse opposite over adjacent. which is tangent inverse 5 over 8.6. So this is 5 and then this is 8.6, right? So it gives us 30 degrees. Okay, so if you have questions, please let me know. If you don't have any question, then please try this example. Okay, sorry, this exercise. So by this, we are now done with chapter 4. Okay, so thank you. Assalamualaikum.